We consume a huge amount of concrete for construction. We consume almost 30 billion tons annually. That's about 4 tons per person. To make concrete, you have to do a lot of things. First, you have to build a formwork. Then you have to lay all the things that go inside the concrete. For example, rebar, HVAC, telecommunication. All of these typically go inside the concrete or in a modern building. There are a lot of anchors that need to be installed so that your fixtures below the deck can be hung from that. And each of these anchors have to be placed precisely to 1/4 of an inch or better precision. And we are planning to automate that process using our robots and mixed reality solutions. There are a lot of repetitive tasks in construction, and one that people particularly hate is rebar tying, where you bend over and bind the rebar together. It's important to tie the rebar together because they have to hold form so that concrete is structurally strong. Our robot can do this in a much more efficient fashion without all the labor requirements for tens of people going around the site and bend over tying rebar.
Where I see Skymul best working with the MEP trades is synthesizing workflows into one singular workflow. And it will be on the deck, doing everything from mechanical inserts, electrical inserts, plumbing inserts, tie rebar, and prior to that, even on the deck, laying out the boxes before the forms are built, limiting the number of people on the deck, therefore limiting exposure to potential injuries, financial costs downrange, giving the ability to work in an off-hour situation when you're not dependent on a typical 8-hour workday.
We are building a robot that can move in these challenging terrains. You have rebar everywhere, you have formwork everywhere, and do real physical tasks. At the same time, also capture the data to make sure that whatever you've placed is actually the right positions and location. And a system that can be nimble and versatile to operate in these challenging conditions are extremely hard to build.
I'm the electrical engineer. I help design the electrical system and work with the outsourced mechanical team on prototyping this robot from the first iteration. Version 0 or version 1 started off as soon as I joined this company, about 1.5 years that we came into this iteration. This is about version 3. We started off as an aluminum frame from version 1 and came into this carbon fiber and more polished electrical system. Ideally, for development to get into work, we try to use as much as off-the-shelf product as possible. One of the challenge was the floor marking system, which are not easy to integrate to robotic system. So we have to develop our own articulated arm and ink dispenser system for that. For rebar gun, it's made for human to be used. So we have to design a system where the robot can use the rebar gun, knowing the signals from electrical system that we built.
So I'm working on the software primarily. The main challenges that we have with the robot is obviously it is really hard for the robot to know where it is. There are multiple systems that we're using. And inside there's a motion capture system. Outside of the GPS, they're working differently. We have different level of noise. So the biggest challenge for the robot is to somehow work through this noise, understand how to trust the system. And there are like 4 legs. Each has 3 joints, so it's not a simple system to work with. As with hardware, we're trying to maximize the use of off-the-shelf products and libraries that are available. My work is to find the optimal algorithm that works best to achieve our goals, like navigation. We're using the navigation stack that allows us to interchangeably use different algorithms that are available. The ultimate goal is to make robot completely autonomous, so it knows what it does and knows where exactly it is and so on. Being on the construction side and the real environment, it's actually helpful to learn what actual obstacles or challenges we might find for the robot, because simulation is one thing, then having a real world environment is the other. So it is a great opportunity for us to learn better and tune robot better for the real environment.
Bringing sustained transformational changes to a traditional industry like construction requires us to provide 10x value to the customer. This means we have to solve a lot of hard technical problems. If you are an engineer or a researcher with a fire to solve hard problems and also work outdoors, we'd love to have you in our team. We'd also like to work with partners like innovative self-performed general contractors and investors who share our passion for the construction industry.